Welcome to this explainer. Look, today we are unpacking an idea that fundamentally challenges everything we think we know about existence, observation, and quantum mechanics. We're going to take some of the most complex, heated debates in physics and distill them down into a genuinely radical new philosophical framework. So buckle up.
Let's just dive right into a profoundly deep question. We always kind of assume that the way we measure and see the world is, the way the world actually exists. But what if our entire scientific viewpoint is literally just a trick of our own very specific vantage point? Let's act like detectives for a bit and explore 3 totally different ways to view the universe.
First up, the thesis of our journey. Everett's many worlds, or the thesis of quantum reality.
Okay, so the crucial thing to understand here is that in the Everett interpretation, reality follows perfect, unbreakable mathematical rules. We're talking about the famous Schrodinger equation, which governs quantum states. In Everett's view, this equation never randomly collapses. It is entirely 100% deterministic. It just keeps flowing, perfectly obeying its strict mathematical laws without any chaotic jumps or unpredictable interruptions.
Now the wild, and I mean literally mind-bending, implication of that flawless math is simply this: with many worlds attached. Think about it. If the math never collapses into a single outcome, it means every single possible outcome dictated by the equation must actually happen. The result? We're talking an infinite number of branching, parallel universes popping into existence every single fraction of a second.
But infinite branching universes are a pretty tough pill to swallow. Which brings us to the antithesis, the case against Everett.
This brilliantly sets up the ultimate cosmic disagreement, right? On one side, you have perfectly ordered, deterministic math suggesting infinite worlds, but on the other side, you have the chaotic, messy, highly subjective reality where you and I actually seem to wake up, spill our coffee, and just go about our day. Critics argue there's a major flaw in Everett's pristine mathematical universe, and it is rooted entirely in our everyday lived experience.
So the case against Everett really boils down to 3 undeniable points. First off, we absolutely cannot ignore the existence of observers. That's us. Second, these observers make measurements. And third, when we actually measure things in the real world, we don't experience some clean sci-fi split into parallel universes. No, we experience a single outcome. And undeniably, there's some randomness to that outcome. The math might be clean, sure, but the actual act of observing is just inherently messy.
So what do? Reality is one object, the synthesis.
If Everett's infinite worlds are just way too impossibly neat, and the alternative is entirely random chaos, how do we reconcile this? Well, the source text transcends this debate entirely with a massive paradigm shift: the idea that reality is one object. Just think about the weight of those words for a second. What if reality isn't endlessly splitting, and what if it isn't randomly jumping when a scientist looks at a particle? What if reality is simply one, single, unified, whole entity? It just is.
Now you might be wondering, a static, single object doesn't exactly explain our dynamic experience, does it? Well, the text goes on to say that this singular reality object is capable of incorporating another level. This is where the framework gets truly fascinating. Reality is a unified whole, yes, but it actually has the architectural room, so to speak, to host a completely distinct layer of existence right within it.
Which brings us to the ultimate twist: the human perspective. So how exactly do we fit into this single object reality? The text outlines a really fascinating progression. Step 1, reality simply exists as one vast object. Step 2, at a secondary incorporated level, the human perspective is introduced. And step 3, actually this is the real kicker here, because we exist at this secondary level, interpretations have to be introduced for reality, in a quantum mechanical way. Basically, the weirdness of quantum mechanics, it's not actually a feature of reality itself. It's just a coping mechanism. It's a complex language we literally invented just to process the sheer massive scale of that single object from our super limited vantage point.
It is a stark contrast for sure. On one hand, reality itself is one independent object. But the human perspective? We need interpretations. We introduce randomness. We absolutely rely on measurements. Our narrow human perspective, with all its messy data gathering, is fundamentally disconnected from the vastness of reality itself. We are essentially looking at the entire universe through a tiny, distorted keyhole.
We desperately try to categorize the infinite, right? But the text leaves us with this bold, definitive conclusion. Interpretations are all from a human perspective and have nothing to do with reality itself. Just let that sink in for a moment. Every quantum theory, every mathematical model, Everett's many worlds, the whole measurement problem. They are merely a human lens. They are entirely a product of our specific vantage point on that secondary level. And they tell us absolutely nothing about what true reality actually is.
Which leaves us with one final, deeply unsettling thought about the extreme limits of our own perception. If all of our brilliant physics and quantum mechanics are just a byproduct of our human necessity to interpret things, if they literally have nothing to do with reality itself, then what is reality actually doing when we aren't looking? It really forces us to question whether anything we see is actually what is. Thanks so much for joining me on this explainer. Keep questioning your perspective, and I'll catch you on the next one.